Good morning, everyone. Today, we are going to talk about something you use every day without realizing it. Yeah, that is your operating system, especially Linux. So, tell me, how many of you use a smartphone, laptop? Have you heard of Android, Windows, Linux? See, Android, Windows, Mac OS, all of them are operating systems. So Linux is also an operating system and it works silently behind the scene, like a manager. So in a very simple definition, an operating system is like a manager of a company. It doesn't do the work itself, but it controls everything. Okay, right? So let's start our today's lecture. Let me share my screen. Okay. Even when you click one button, the OS is doing many jobs, right? The three main responsibilities of our Linux or operating system is first one is manages processors and memory, handles files and devices, and the third one is controls who can access what. Okay, I will give you a very simple example. Just you have to relate it. Okay, think of a school. Students are same as the programs. Suppose students are programs, classrooms are memory, principal is operating system, and rules are permissions. So without rules, the school become chaos, right? So what happen if anyone enters any classroom anytime? Yes, there are lots of confusion. Okay, lots of confusion are created. Okay, so what is a process? A process is a running program. For example, Chrome is open. This is a process. Music player running. It is a process. Game running. It's also a process. Okay. Important line about the process is install program is not a process. Running program is process. Okay. See, Linux have to start programs, stop programs, pause programs, resume programs, handle crashes, right? If I give you a real life example, so imagine a traffic police at a junction, right? So he decide which car goes, which car waits, what happened during an accident. So Linux does the same with programs. Have you ever heard about deadlock? Deadlock means two programs are waiting for each other and nothing moves. Okay? Simply, a process is a big task, a thread is a small part of the task. Okay, I will give you example like opening YouTube. One thread loads video, one thread loads command, one thread handles add, right? All inside one process, right? Imagine when you open a YouTube, one thread loads a video, one thread loads comments, one thread handles ad. They are all inside one process. So you can say that thread is a small part of that task and process is a big task. Thread helps programs work faster and smoothly, right? Okay, let me ask one question. Have you seen apps not freezing even when loading? Yeah, that's because of threads, right? Okay, memory management basic. So, what is memory? Memory means RAM. RAM is like your study table, a bigger table, more book open, faster study. A small table, keep removing books. This is slow. How Linux manage memory? See, Linux decides what stays in RAM, what goes out, what comes back, right? Linux is a very smart and efficient with the memory. Okay, swapping and paging. Swapping is when RAM is full, Linux moves less used data to the hard disk. Okay, and paging happen when memory is divided into small blocks, like pages of a book. So Linux keeps only important things on the desk and moves other to the cupboard. See, in Linux, files are stored inside directories. Directories are like folders. Okay, look like a tree. Everything start from the one root, just like your address. If you want a real life example, then suppose just like your address, it is means house uh, tends to street, street tends to city, city tends to country, in a hierarchical manner. So Linux uses paths to find files. Okay, access control. Uh, why? Why there is a permission to need? Why there is a need of permission? Should everyone be allowed to edit exam question paper? Just give me answer. Should everyone be allowed to edit exam question papers? No. No. So there are some logics in Linux. For permission, there are some keywords like R is used for read, W is used for write, X is used for execute, and in Linux control, it can decide who can open a file, who can modify it, who can run it, right? In a real life ATM card, decide if you are a holder of an ATM card, you know that you can see balance, you can withdraw, others cannot, right? So, today we learned that Linux manage programs, manage memory smartly, organize file neatly, and protects data using permissions. Okay, Linux may look complex, but inside it works just like common sense, only faster. Okay, okay, perfect. Okay, students, at last I have a set of questions with answers, which is designed only for this lecture. Linux, the core responsibilities. Okay, so I suppose that you will be answer my question. So, okay, the first module of my question is what an OS does behind the scene, right? So, the first question of this module is what does an operating system do behind the scene? An operating system manages process, memory, files, devices, and security without the user noticing, right? Okay, second one, why don't users see most OS activities? Okay, the answer is because the OS works in the background to make the system run smoothly. Okay, the third question is how does the OS help users? The answer is allow it allows users to run programs easily without worrying about hardware details. Okay, the next one is what happens if the OS fails? The answer is the system may freeze, crash, or stop working properly. Okay, so let's move on next module that is process and process management. So the first question is what is process? The answer is a process is a program that is currently running on the computer. Okay, next one. Give examples of process. Yeah, there are lots of examples like web browsers, music players, video games, and background services. These are the process. Okay, next one. What is process management? See, process management is the OS function that controls how programs start, run, pause, and stop. Next, why is process management important? It is important because it ensures that multiple programs run smoothly without interfering with each other. Okay, next one. How does Linux handle many processes at the same time? The answer is Linux uses scheduling to share CPU time among process efficiently. Okay, next. What happens when a process crashes? The answer is Linux isolates the crash so other running programs are not affected. Okay, let's move on our next module, that is threads versus process. And the very first question of that module is, what is a thread? Remember, I told you about the thread. Okay, a thread is a small unit of execution inside a process. Okay, next. How is a thread different from a process? A process is a complete program, while a thread is a part of that program. Okay, next. Why are threads used? See, threads allows faster execution and better performance. Next, can a single process have multiple threads? Yes, a single process can have many threads running together. Okay, let's move on our next module, that is memory management basics. And first question of that module is, what is memory management? Memory management is the OS task of managing how RAM is used by the programs. Okay, next, why is RAM compared to a disk? The answer is because more RAM allows more work to be done quickly, like a bigger disk. Okay, next. What happens when RAM is fully used? The answer is the OS uses special techniques to free memory and avoid system crashes. Next, how does Linux decide which data stays in RAM? Linux keeps active and frequently used data in RAM. Okay, next, Let's move on next module, that is swapping and paging. Okay, the first question of this module is, what is paging? Paging divides memory into small parts to manage RAM efficiently, right? Okay, next, what is swapping? Swapping moves unused data from RAM to the hard disk. Okay, next, why are swapping and paging needed? The answer is they help the system run smoothly even when RAM is limited. Okay, next, does swapping slow down the system? Think about it. It's a very common, sensible question. Does swapping slow down the system? Yes, but it prevents system crashes when memory is full. Okay, let's move on our next module, that is file and storage management. Okay, first question, how does Linux store data? Yes, Linux stores data in files and directories. Next question, what is a directory? So a directory is a folder that contains files or other directories. Next question is, how are files organized in Linux? Files are organized in a tree-like structure, right? Okay, next one. What is a file path? A file path shows the exact location of a file in the system. Okay, next module is access control and permissions. So, our very first question of this module is, what is access control? Access control decides who can use or modify files, right? Next question is, what are file permissions in Linux? File permissions define who can read, write, or execute a file. I also give an example to you previously. Remember? Okay. Next question. What does read permission allows? It allows a user to view file contents, right? What does write permission allow? It allows a user to modify or delete a file. Next, what does execute permission allow? It allows a user to run a program. Okay, let's have important and wrap up uh, module. Why is understanding OS responsibilities important? Why we are discussing about OS responsibilities? Why? Why it is important? Because it helps users and students use Linux more efficiently. है ना? Right? Next, why is Linux preferred in servers? because it is stable, secure, and efficient. Next, how does Linux improve system performance? By managing process, memory, and file efficiently. Next, what is the biggest advantages of Linux operating system? Yeah, it is a free, secure, and highly reliable. Okay. See, students, Linux is not just an operating system. It's a responsibility, and I'm talking about responsibilities of operating system. So just think, when you use Linux, you are not just a user, you are a controller, right? With great power comes great responsibility, and Linux gives you that great power. Linux teaches discipline, patience, and problem solving. In Linux, every command matters, just like every decisions in life. Okay, so responsibility of Linux as a user is, as a Linux user, you are responsible for your system security. You must update your system regularly. You must not misuse root access. You must respect open source ethics. You must learn before executing unknown commands. You must protect data and privacy. See, Linux trust you. Okay, are you trustworthy enough? There are some responsibility on behalf of root user, which is called super user. And like root has full power. One wrong command can delete the entire system. So always think before typing, verify before executing, backup before modifying. See, in Linux, power is given to those who are careful. Okay, always remember this in your mind. In Linux, power is given to those who are very careful. There are some more responsibility, like responsibility towards open source community. As you know, Linux is an open source software. Now, anyone can change its coding, its functionality. So, the responsibility towards open source community is that Linux is built by thousands of developers. So and it's also free because people contribute. So your responsibility is to report bugs, share knowledge, respect license, and help others. Open source is not about free software. It is about free responsibilities, right? There are some responsibility as a student also, like practice daily commands, don't fear terminal, learn scripting, understand permissions, explore directories, right? The terminal is not black screen. It is a window to your potential. There are some responsibility in career also, like Linux is used in servers, cyber security, cloud computing, supercomputers. Almost all top servers in the world run Linux. So if you master Linux, you control the backbone of the internet, right? So remember, always remember some lines that Linux does not limit you, it challenges you. Second, be responsible. Be responsible. Be disciplined. Be powerful. Right? Learn Linux not just to pass exams, but to build confidence. The command line is simple, future, but your future through it is powerful. Don't just use Linux, master it. Okay. So, with these thoughts, I ended this lecture here. And in the next lecture, we discuss about the Linux fundamentals of about input output, security, and kernels. Okay. So, thank you.